Hello, welcome back to our Plaxis tutorial. We are going to continue with our calculation phase of our ship footing foundation, the circular ship footing foundation sand. This is our geometry that we drawn on Plaxis. So now we are we drawn the model, we reach our calculation phase. So now you see here we have an initial phase which comes automatically. And each is described, if you look here, it describes each phase number starts from, so there's no start from anywhere because the initial stage. The calculation K0 procedure, the remarks say explain what that is. The time 0 day, all this is just, you can input that up here. So you see on the general tab, you can change the ID there. And the calculation tab, if you click here, it tells you 0 procedure of gravity, 400 gravity loading calculation. You can do that. So that's 0, which is at initial 0. Choose the parameter, click on the parameters. It gives the parameter tabs. Shows the proportion cutoff is just all the standard value. You don't need to change any of them. You can't change, you can add any time because it's an initial step. So you cannot add much there at the initial stage. So to add a next stage will be click on the next. It will ask you add another phase, the next phase. This particular model we're doing just going to have two phases, initial and the phase 1. So on that phase 1 is going to be plastic analysis, where you can change. If you go at the top here, calculation type, click on the drop menu. It gives you different kind of calculation type you can do. You can do a plastic or the plastic consolidation calculation type or safety analysis. Each time you click, it gives you kind of a remark of that kind of calculation type. On the plastic, tells you that ongoing behavior will be considered. Let's say if I click consolidation 1, it tells you that the excess proportion will be investigated. If I look at the plastic drain, it tells you that compatibility of water often ignored. A couple long-term deformation analysis. This couple short-term differential analysis on drain behavior is considered. So this is what we're going to be looking at, the plastic behavior. In order to simulate the settlement footing of the analysis, a plastic calculation is required. So this is the reason why we are using that plastic analysis. It will be required to help us to simulate the settlement of the footing. Also, what we need to do as well, if you look at the next parameters, again, in your display water cutoff is just the maximum stress that the calculation will reach under this proportion cutoff, but there's no proportion, so just don't worry so much about that. If you have a time interval, we can add it here. Let's say if I'm doing a consolidation analysis and I'm doing it in 24 hours, then I can add it 1 day here. That's my time interval is 1 day. As if I put 1 here, you just automatically add the 1 day in the estimated end time. So end time added in 1 day. So, but I'm not having to leave it at 0. The calculation is going to be a star calculation. Because this star calculation, what it does is, if you click on the advanced, it gives a maximum reach value at the end of each calculation phase. So it's telling plus that once it reaches that value here of 1, which is a multiplier, then that is the end of the calculation. So that is kind of a maximum value for the calculation phase to be completed. Now, if this value is less than 1, you can have a value less than 1, depending on the type of model we are simulating. And we talk about it in one of the tutorials that we will do involving tunnel. When involved tunnel with tunnel lining, then you can have a value less than 1 during the simulation. When it comes down, we'll talk about it in more details, but in this particular case, we are using a value of 1. Now, this additional steps here, 250, is sometimes you do a model and the model will fail because because the maximum steps were not reached, which means that when plastic was doing the calculation, it could not finish the calculation because this value is too small. So what you can do is increase it. So when it fails, you go to general tab, a message will pop up here telling you why the model failed and using the reason that you can fix whatever the reason is. And if one of the reasons is because the maximum load step was not reached, just increases value to give more range for plastic to finish the calculation. Now, to do our simulation, we are going to activate our displacement. Our prescribed displacement, add a value to that. So we click on define. it takes us back to our model. You can see that displacement is gray, which means that it's not activated. So if you calculate your model now, all you're doing, you're just simulating your soil with no displacement, no value at all added to it. So what I'm going to do is, if I double click on that line, the prescribed displacement static load apply, you can see if y, x and y direction, but we are working under the y direction, which is the negative value to apply a downward displacement. So we are going to take that value to be, let's say, 0.1 minus 0.1 in both this column. So call it 0.1. You will do exactly the same if it was a load. So if it was a load that let's say if it was a line load which was applied, we double click on the line load and apply the load. If it's 5 kilonewtons, you put 5 minus 5 kilonewtons. So for the displacement, it will be minus 0.1 in both. Okay, so you just click OK. Now you can see that it's blue. So we have activated our prescribed displacement. If there's any water condition, if it's saturated, you click on that water condition and then you add. Now the default is at the bottom, so because there's no water. But if you want to add any water level, you will go there and add water level, whatever dimension it is. But in our case, we don't have any water level, so we just go. We've done our prescribed displacement. We don't have any saturation, 0. So you go on to click update. So we've defined. So now we've defined our phase 1 into plastic stack, and we've gone into our model and activate our prescribed displacement. Tell the plastic, okay, that's what we are calculating. So we activate it to say that we add a displacement minus 0.1. So that's why it goes to be applied to that sample. Now to calculate the model, you click on calculate. Now, ideally, you're supposed to select source points and node points. Those points are used to plot graphs. If you don't select them, if you don't have them, if you don't select them, you can see conduct your calculation without it. So let's say that I'm going to select it. Select it now. It takes me back to my model. Now, depending where where your maximum settlement or pressure will occur, that's where you can plot. Now, I know that my displacement is at this side. So I know that when that displacement minus 0.1 is applied, it will push the soil downward to the 8 points. So I'm going to take some points at this area. Let's say I take a point here, a point there, and then I take one at the edge there. Just going to click onto something appears. Sometimes it doesn't appear. So I know that at this area here, that is where that load will push down to the soil. So around this area, I'm expected to get some reasonable curve, something. So I'm at one of these points. You can take one of these nodes to plot your graph if required. So click here to update, and then now you can do your calculation. As you can see, as you're calculating, you look at this window here of the graph being plotted. It shows you how the graph is being plotted, the deformation against your force. So that's your force of displacement. It shows you a graph of what you are likely going to obtain at the end of the calculation phase. Sometimes depending on what you've selected, let's say if I had taken a very fine mesh instead of the coarse mesh, the calculation time will be longer. So it will take a longer time to calculate your model, simply because it subdivides your soil profile into more finer elements, which means that will take time to calculate all those elements. But if you think coarse mesh shouldn't take very long, so you're just waiting for the maximum load step to be reached. Once it's reached, the calculation will end. Now see here, it tells us this phase has not calculated. It says not enough load steps. So what I will go is go to parameters, additional steps. I will increase that to 500, and I will do the calculation. I will just turn this back to blue because it was regular to calculate, and do the calculation. You can see one example when it fails is because of that. So 250 was too small, so I've increased it to 500. You can increase it to 1000 if possible. So you just do the increase until the calculation completes. So you can see it's taking a bit of a while to complete it. So that could be the reason. That is the reason why. Sometimes it go faster. It depends on the type of model and everything. So. Hopefully the 500 should be okay for it to reach, but if not, we'll put it to 1000. Yeah, if you can see now everything is completed. You can see it's all going off. Once it says it's okay now. To view our result, you click here to view our calculation result. Now this what we expected, because this is where our displacement is, so it's going to push it downward. And at the bottom it gives you kind of a maximum value, 0.1 meter. Then you can add that 0.1 meter is the maximum value you've added for the displacement, so that was the value you added. If you look at the top here, it gives you different here geometry, the mesh. You don't really need that, the mesh, because you know how the mesh is. Deformation and stress, it gives you different option to view how you want to view your soil. If I go on the deformation, it gives us different kind of profile. Let's say I want to present the total displacement in the water. If I click on that here, it gives you that color, and it gives you the legend here to explain what the color means. Like I can see at the top here is more the red bit that tells you that is the maximum. That's where the maximum displacement is occurring. So this is the legend to present the color. And at the bottom here, it also gives you the, also look at the legend, you can also look at the value, like the maximum value here is that value 0.01. And then we are looking at phase 1, which is the plastic. We don't need to look at the initial, because it's initial, so nothing is happening at that stage. It's just the initial condition of the soil. So always look at which phase we are looking at. So each phase we have kind of different behaviors. So if we go back to phase 1, which is where we are looking, it gives you this, what we're looking to, the displacement UI. So this gives you this how you present your result. At the top here, you can present it in with arrows if you like, or you can leave it as it is. If you want to look at stresses, let's say I want to look at the total stress. So this is what it gives you. If you want to plot a graph, you just go on the curve manager, new. Let's say you want to put a project, pick a point A, like the point that we selected, but axis. I want to plot the deformation against stress. Let's pick excess. So it don't give you anything. So you will try plotting a graph at each point of each of those node points you selected until you get something reasonable. Because some of these points, stress point will not give you any kind of information on the graph. If you want to present a graph, that is how you're going to plot them. If you don't want to present a graph, you just want to represent that option, say nothing. So you will try until you get something reasonable. So that is basically how don't want to save it, because that is not what we want. It doesn't give you anything reasonable. So we've only plotted 2 points. You can plot many other points able to show you everything. So that is our result, of your model that you can present like that. So that's